Yeah, Twitch says we're streaming, so I'll go tell everybody on the internet. Because they all listen to me. Streaming game dev. Probably gonna do a robot arm! Exclamation point paste. All right. Sorry, I'm looking at just a couple of things here at the last second. I'm a little slow today because I only got about 4 hours of sleep, and it's definitely a little tiring. But I think what we'll do today is some robot arms. What we're going to want to do is have some method to actually pull electronics out of these electronics bins. And the thing we're going to need in order to do that is to animate an arm that can go and grab that stuff. Obviously, we're going to be using some inverse kinematics. One of our options is to use inverse kinematics that are built into Unity, but let's not do that. Another option is to use the really good inverse kinematics libraries that I've got, which is probably the best idea. If we pop over to the asset store and my downloads, I should be able to filter by Final IK. I don't know whether I downloaded it recently. No, Final IK. What kind of idiot changes the filter back after I've typed something? It's been a problem with YouTube recently too. YouTube will pop up and it'll autoplay and I'll hit pause and then it'll autoplay again. So, come on, I know that I've got Final IK. So Final IK is a really good tool, but obviously I can't give it out. So this not being a project I plan to give source code for, it's okay if I use it here in my more final game. I may have to replace this with a custom programmed thing that can be distributed. No big deal though, I'm just using some basics. Obviously I have to model a robot arm, or import a model of a robot arm, depending on how I feel about it. But I know that the model of a robot arm that I have in the other game is not actually IK-able. It doesn't have proper joints. So we're going to go ahead and put it in with some proper joints. The other problem I've got with Final IK is that it's built specifically for humanoid arms. I think you can fake it, do some other stuff with a faking. I think you can make it do other things, but the problem is, now that I'm thinking about it, I may want to have like a very robot-feeling arm, either like a tentacle or one that has very clear rotational gimbals. Well, let's go ahead with Final IK for now. We can always change it out later. So we'll go ahead and make it a humanoid arm for our Final IK first pass. And to do that, we're going to pop on into the small ships file and build ourselves a robot arm. Well, let's go ahead and just move that out of the way and then hide it. Now, a robot arm is very similar to a human arm in this case, because we're using a human system to animate it. But what should it look like? Generally speaking, we're going to want to have an arm which puts things away into a little knapsack of its own. So we're going to model the arm and the knapsack at the same time. And that should work fine. So, oh, I just smeared my glasses. Brilliant! I was like, I'll clean my glasses, or I'll make them substantially worse. Alright, so what we're going to want to do is create a base and a box and a couple of other details like that. But we'll start with a simple x-axis mirror modifier, because that's always fun. And then we will, there we go. So the base that we build on is going to be put up against the ship. And what sort of base? I'm sort of thinking about the arm. Well, why don't we just sketch it? We'll go ahead and just sketch the arm before we do anything else, okay? So if we're looking at it from the side here, we're going to need an arm that can reach out like this and grab some stuff. There's our little grippy arm. And that means that when it comes back in, it's going to be like this, right? A little grippy arm. So that means that we're going to want a forearm that's a little bit longer and an upper arm that's a little bit shorter. We may even want like an extendable arm, but we'll do that later. This is just going to be a first pass. All right, so now that I know what we want, we're going to want to make this area a sort of bag where we can store our ill-gotten loot. And I think we're going to want like a coffin shape. So something like that should do pretty good. And then we'll bevel that. Yoop. Okay, there is a line there. I just can't see it. Brilliant. Okay. So I'm going to undo that and then bevel the whole thing here so I don't get a weird, vaguely not quite right quad. And we're going to want to make it so that there is a another cut here. Yeah. And then we'll grab this face and we will extend it and shrink it like so. There we are. And that will be where our things get put. We'll go ahead and give that a little bit of depth just for the moment. But we're also going to want to create a hood for it, you know, a cover. And so we'll just duplicate this and then we will fill it in. Oops, I screwed that up, didn't I? There we are. We will fill this in by extruding on the x-axis like so, and then filling in these here. Oh, that's not right. Here, and then we all want to flip the visual. Flip. There we go. This is obviously not a complete cover. We'll go ahead and extrude down a little bit and flip again. Brilliant. And we're going to want to put in like a little bit of a hinge or something just to give it, you know, a little feel like it actually has some ability to move. The easiest hinge to put together is just a very basic circle hinge. So that's what we'll do. Oh, I can't do that with clipping on. There we are. What the heck's going on here? Oh, I'm on face mode. There we are. Go ahead and flip that direction, seal off this edge, and then bring it in. And then we'll just bring the whole thing forward just a touch. Actually, I think what I want to do is extrude these faces on the y-axis. That'll give it some serious depth, which will be kind of nice, right? Last thing we want to do is just run a connecting line so that we can select it all with L. And that way, it's ready to rock. So we're going to want to bevel these surfaces so that we can get a real good sense of there being a crease there. So to do that, we're going to select all of these points that we need to select, like that. And just do a little bit of a bevel, not too much. That's way too much. There we are, like that. We're going to repeat the process down here with a little bit of a bevel, like that. And then we'll just drag this down. And we will Z. There we go. Perfect. So now the coffin shape is not done, but it's ready to be practiced on at the very least. Now what we need to do is have an arm. So there's a lot of ways that we can build an arm, but I think the best way for us to do this is to have it come out of this joint here. And the best way to do that is probably to extrude here and then scale down on the x-axis only, like that. And then we will want to just grab specific edges to move them into a vaguely better position. And we're going to want to scale x0 this guy so that it feels like it's coming out properly. When we delete this vertex, we end up with a relatively nice indent. The only problem being that we need to have it match the upper element, so scale that down, and then we'll match and match. There we are. And we're going to go ahead and bevel this edge like so. Give ourselves a little bit of a slope there. Might as well do it again. There we are. And now what we're going to do is we're actually going to select the whole thing, smooth it, and then put on an auto smooth of 30. Yeah, that way we get a little bit of gentle curve going on here. So now we need to put an arm in here. So the biggest issue with using Final IK humanoid arms is that the shoulder joint is going to be a ball joint. The elbow joint is a linear joint, but the ball joint is going to look odd if it doesn't have a ball shape to it. So let's experiment with some ball shapes. I think that a UV sphere makes for a pretty good ball. Let's bring down the complexity of this a little bit, and then see if we can move this into position. Well, just in a basic sense, it's not going to work out very well because this isn't a ball-shaped hole. So if I were to just grab these points, maybe I can just grab this one point and bevel it. Can I bevel a single point? Apparently I cannot. That's a shame. But I could do a cut. So we'll go ahead and cut a triangle here. And now we should be able to bevel the inner elements like this. And now if I grab this guy, we should be able to soften that. Doop, 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 doop. There we go. Just a little bit of roundness to it. Can we soften it one more time here? Yeah, that's what I'm looking to do. I'm looking to get some nice smoothing there, but that should be good enough for now. What I can do, I can continue to soften by selecting these edges and beveling them, as you might have expected me to do. And that will create a smooth curve with no hard edges. And that's more or less what I want. I'm just not sure yet that this is going to work out. We'll give it some more shots here. So if we grab this as a ball, we can just move it 0.5 and then shrink it some and then move it up 0.5. Come on. There. And then shrink it some. So you can see that the core issue here is it's just not the right size to fit into that compartment. If I scale it back up and rotate X90 on it, there we are. I would need it to somehow fit with this configuration. I think the answer is to make the ball joint quite small and bring these edges in. Let's go ahead and try it. Scale 0.5, GZ 0.5, GY 0.5, rotate X90, there we go. If we bring in these edges, we might be able to get a good feel. hope I didn't accidentally merge any. How many? Just one. Good. That's correct. So if I do it like that, it looks more right. So what I'm going to do is I'm actually going to have this ball joint be a little bit more interesting. So we're going to turn off clipping so that we can do this. Oops, that's not right. Center, please. We're going to do it like this, and what we're going to do is we're going to have the top turn into an arm element that's got some flatness to it. Now I do have X mirroring turned on, so I could delete half of this ball, but that would make it a little bit difficult for me to do some of this shaping that I'm doing. So we're going to go ahead and leave it as is. There we are. So now what I can do is I can bring forward all of these faces. Just on the y-axis strictly, please. That's a lot of extra faces, but Dot Bow says, what is my primary profession? I program for a green energy company. So mostly it's databases and some front-end work. So game dev is just a hobby for me, which is obviously something that not everyone wants to do with their free time. So if we extrude this on the x-axis, we can get it sort of pinned in and feeling right. But the problem is this ball joint is going to rotate on several axes. It's not going to feel right. Unless what we can do is actually make this part of the brace rather than part of the arm. Yeah, something like that. It's still not going to feel quite right, though. We'll leave it like that for now. What I want to do is cut this with a scale Y0, and cut here with a scale Y0, like so. And then what we'll have is a nice flat area that we can start to build into our secondary joint. We're going to need to have a longer limb that comes back and drops stuff in here. So for that, probably the best thing we can do is create another cube is probably better in this case. I don't think we need a circle this time. So we'll scale this down 0.25. And what we're going to want to do is just have it be the right length for starters. We will adjust the pitch of it when we're done adjusting the length of it. Yeah, that's about the right length. And then if we rotate X 15 degrees like so, that's more or less the correct pitch for our elbow. If we were going to drop something in, maybe this is a little long, so we'll just cut a little bit off the tip. Boom. Now what we would need to do at this point is set this up so that it fits into a slot on the upper arm, which you've noticed I have this little cut here that's specifically engineered to be the right size. So all I have to do is make that cut a thing that actually exists. I'm going to cut there too, so that we can, actually do our X mirroring at some point, whenever it's convenient for us. So once we've done this, we can extrude, and then we can scale down on the x-axis, like so. And then we can scale down just with individual edges on other axes. Just deselect these guys. Actually, that's not how I have to do it. I will just select that. There we go. And I'll go ahead and use that active element as what we're scaling towards. That way we won't get any sort of deformation at the edge there. There we are, like that. And what we actually need to do is delete these three verts and then fill this gap in, which we'll do in a minute. First, though, we have to decide how this joint is going to look, and I think the easiest thing for us to do is create another UV sphere. And just put it in vaguely the right place. Something like this. Now, in the long run, we'll need to do a better arm, but I think for now this is fine. Let's go ahead and hide the arm. And we should have a gap, but we don't. I thought I deleted these verts. Did I delete them? Oh, I somehow deleted the wrong ones. I hope that didn't create a hole somewhere. Still got a few left to delete here. There we are. So what we're going to do is just grab this edge, which should be... we don't need all of it. We only need the top port. Like this. In fact, we don't even need these guys. And we'll extrude that straight down, like so. And then we'll go ahead and start to fill in the gaps, which will be... Why don't I go ahead and turn this invisible for a minute so I can see what's going on. So, gap, gap, gap. What we're going to need to do is combine these elements. So scale 0, and that's not the right way, is it? I guess it is. It's fine. And once again, if I turn the mirroring on, I won't have to worry about this. I think it's probably about time. Let's go ahead and turn that mirroring on. Dotbow says, where did you get your level design knowledge? I really like the vids. So helpful, and you really sound like a professional in this scope. Mostly by being very old. I mean, I'm not galactic scale old or anything, but over time you pick up a lot more stuff than you might think. You spend some time doing level design for mods and small games, and you know, a lot of it wears off. I think a lot of people want to watch, you know, like GDC videos on level design, and that stuff's valuable, but nothing can really be as valuable as simply having practiced it. So I really recommend, if you're interested in level design, you should strongly consider the idea of simply designing levels for any game that lets you design levels. There are a large number of them on the internet these days. So, you know, give it a shot. Of course, you can also play levels with an eye towards critiquing them. That will also be valuable. Another thing to consider is that while level design is often considered kind of a monolithic thing, like, oh, you design levels well or you don't design levels well, in a lot of cases, level design is dictated by someone's personal preferences. So you'll find people that are really, really great at designing specific kinds of levels and really, really awful at designing others. And I'm sure I'm that sort of person. So, you know, if you agree with my level design talks, that's fine, but you also have to find your own voice. You don't want to be stuck using mine. All right, so now what we need to do is put the hand onto this thing. And it's going to be basically the same thing we just did, except we're going to cut out quite a bit here and create a really deep groove for the hand. So these three elements we're going to want to extrude and then scale X down. My bad. Turn on clipping and then extrude and scale X down. That's better. And then we'll just delete this end vert like so and close this gap up. dear. That's fine. I should have designed this as a flat arm, but that's okay. Excuse me. Topow says that GDC boring. GDC vids are usually pretty boring. That is unfortunately true. They're not really built to be exciting. They're less boring if you know exactly what you want out of them, but if you're just cruising level design videos, that's probably not the case, and you're going to get real bored. Nothing wrong with that. As I said, the best way to learn is to actually go do it. So, that's what I recommend. So for our arm, we're going to want to create a cylinder here. Rotate X 90, rotate Z 90. There we are. Turn clipping off so that we can do, I guess, clipping off. And then we'll want to shrink this and then extrude it on the X axis. We'll turn clipping back on. And obviously this is going to be the hand hinge. The problem, of course, is that the wrist is also a ball joint, so I shouldn't be doing this. God damn it. So we'll go ahead and create a UV sphere. Can't get enough of these UV spheres. Oop. We'll just nestle this sphere inside of this joint. And we will go ahead and create a little bit of a bevel here if we can. It doesn't look like it wants to bevel. This is a tough spot to try and bevel. I guess the better option would be to cut here and here. And then what we can do is delete that vert and join this thing together. Now the big problem is we've got a convex face here. See that? We're just going to go ahead and cut that so that Unity doesn't get confused. And then we can pull this back a little bit. I guess not. We don't want to pull that back any further. So this hand is going to just be a set of pinchers, I think. And we'll just do it nice and simple by extruding from this sphere in a pincherly manner. You'll notice that this is not the same, the pinchers are not the same, and that's because we're not doing it symmetrically. So we've got a real lightweight upper pincher and a real solid lower pincher. And to be truthful, we don't even want that, so let's go ahead and get rid of those. What we're going to do instead is duplicate these, and the reason for that is so that we can have separate pinching elements, so we don't have so we don't have the sphere deforming. We'd like a more robotic feel. In the long run, we'll probably want to replace this with something that actually stands on its own. It has like robotic feeling elements to it, but for now I think this will work fine. We'll just go ahead and brute force it. Ooh, too much. Flip that. All right, so that's a little bit big. We'll go ahead and pull these in just a touch. Actually, I guess it's the other one that's a little small, since we actually need to be able to grip stuff, so it needs to be pretty long here. This is a little bit silly looking. Let's go ahead and try again. What do I want the gripper to look like? I guess it should just be like a... You know what? I'm thinking now. One of the funny grippers that I've seen that seems like it would be very good for this is just a soft foam gripper. The way it works is that you press your soft foam bulb against the surface of something and let it deform around the thing you're trying to pick up, and then you harden it, and it ends up being holding the object that you're trying to grip. And it works pretty well, so I think what we'll do is we'll go ahead and do that because it's funny and easy. Why not, right? And the way we're going to want to handle this is we're just going to extrude straight back on these center elements, like that. And that's all we're going to do there. But we do have to delete half of these verts. Jaboom. Perfect. And we're going to want to smooth those faces, and right. Now I think it's time for us to, you know what, there's no way that's actually going to be able to put stuff into the bin because that's too short. So we'll go ahead and just make this a little bit different so that it can fit stuff in the bin. Dotbow says, that's actually a fun thing about job versus hobby or whatever. I'm learning programming in a lot of DB in university, but I also heavily learn 3D modeling, texturing, and game dev. Yep. It's always good to have an interest outside of your classes. If you just go with your classes too much, then you're going to end up being a very overly focused, nothing outside of the one thing that you were taught, and that's just not very good. So I do recommend having hobbies outside of your classes. That way you'll know what you want out of your classes at the very least. All right, so that's a little bit better. So with this in mind, we're going to go ahead and build ourselves an armature. Doop, 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 doop. There we are. And we're going to call this mechanical armature. It's the mechanical armature. So we're going to make this just the base joint. We're not going to worry about that too much. Then we're going to extrude out over here. Now this base joint actually has to be moved half a step that way. There we are. And then this joint here, bring it in and up. Yeah, that works. Then we'll extrude this up, and then we'll extrude this forward on just the y-axis. Boom. And then last thing we're going to want is a joint to actually do the compression. So that's what we'll do there. And we also need joints to control the lid. So we'll just bring this back and up. Back and up. Back and up. There we go. And then forward on just the y-axis. Let's name some of these bones because it's much easier to actually remember what they are. Lid, that's lif, lid. We don't actually need this bone, so we'll delete that. There we are. So this is the lid bone, and it's doesn't need to have any other purposes. This is going to be the shoulder. This is going to be the elbow. This is going to be the wrist. And this is going to be the grabber. Perfect, right? Maybe. Let's go ahead and name this the mechanical arm. Let's go ahead and give it some materials. Right now it is completely unmaterialed. So first things first, we're going to have hull, and then we're going to have some interior, and we're going to have some warning. Boop. So for warning, we're going to go ahead and color this joint, just the joint element, with the warning material, and the ball here, also a warning. We're gonna go and make this just a visual that I can see through, because it's too frigging loud. So no, not bounds. Bounds is a little too low. Wire, that's good. So those are now warning. I think I'm going to want to make all of the joints have at least some warning. So how about I'll go ahead and make this whole thing a warning. And then here, this is going to be a warning, except not here, so hide that. Grab this. Warning. No, unhide. So now we want to put in some interior marks. Let's go ahead and make this interior. We'll obviously make the interior interior. The bottom will be interior. Guess I'll make these as well. Come on. You hide. Yeah, you hide too. All of these should be interior. Boom. There we go. Unhide, please. And we'll make you, and there we are. And this joint here, interior, and the interior. Boom. All right. So that's more or less fine. We're not going to be too worried about it. We're not doing any actual UVs, but it's generally worth unwrapping them anyway. We're going to be using some non-UV methods to decorate these things. I see that I've missed a few little pieces here, though. So where is the center joint? There it is. There we go. Perfect. It's all interior. And lastly, let's go ahead and make this door element interior. Doop. Actually, let's have this side be warning and this side be interior. Boom. All right, so now what we have to do is actually assign the joints. So we'll go ahead and select both of these, hit Control J, now Control P, with automatic weights. And let's just go ahead and see how badly these weights screwed up. We're gonna have to do some painting here, for sure. For starters, this joint should only affect this door. So we're gonna grab this and we're going to go ahead and change over into weight paint mode like so. And we're going to want to turn on a couple of weight paint mode things like auto normalize. We're going to go over into this joint and we're going to want to make all of this stuff red. But in order to do that most easily, we're going to go and select all of these and hide them. And they don't stay hidden. I thought they did. That's interesting. Why can't they? Well, if they can't stay hidden, we'll just punch them out into their own object for the moment, and we'll come back to it in a minute. But it has to be its own object so that we can weight paint like interiors and shit. Otherwise, it won't work out very well. Normally, I'd use a. I guess we should probably just separate all of these out now that we're doing them. There we are. We'll recombine them later. There shouldn't be any problems. Normally, I would use my my tablet to help do this, but we're not doing anything complicated enough to require a tablet today. This is very basic stuff. Just painting things flat red should be fine. However, I'm having a hard time. There we are. And I think there are other ways to do this. I still am not comfortable weight painting in Blender. Normally I go to surprising lengths to try and ensure that my model's automatic weights end up being perfect. But that's not possible with robotic stuff. That's only real possible with organic stuff. There we are. Boom. And then, of course, if we rotate that, we'll see that if we grab this and rotate this, you can see it no longer does anything, which is perfect because we have a... no? Alt-H? Where's my... Ugh. Alt-H, there. This is the only thing that should be affected. Yeah. It looks like this has some verts in it that I don't need. No, it's just not behaving well for some reason. It's interesting. All right, so let's continue on with our painting job. This guy should be painted entirely with this joint here. So that should be fairly straightforward. Just paint. Dotbow says I can make vertex groups and assign it. I don't really know. I don't really know how to do that. I'll look into it later. Right now, it's kind of relaxing to do it manually, so we'll keep doing it manually just for a little while. Weight paint. And this is mostly correct, but not quite. We'll just go ahead and finish off the little details that need to be done. There we go. And seems correct all around. Good. Lastly, it is this guy. Weight paint. So this guy has the most complicated weight paint job, but it's still not very complicated. Yep. And that's actually right. Perfect. So now we'll just recombine all of these things. Boom. Boom, boom, boom. So hold on, we'll start with this guy. And make sure it worked. Yeah. And then we'll move this guy to this guy. Yep, that's fine. This guy to this guy. Yep, that's fine. All right, so now when we move this, you can see that it should move more or less like a real arm might. Got some decent reach. Should work. All right, so that should do. Save this, go back into our Unity program, and we'll go ahead and set this up as a final IK object. So I don't know whether we have any small ships. No, we don't. So we have to drag this in and do this manually, which is fine. We're going to drag the mechanical arm into the armature because that's the easiest way to do it in Unity. We'll delete this, cruise on over to it. Let's move it somewhere that's not in the middle of another object. You know what? Screw it. Let's move the other object. And you can see that it's more or less the exact same as it was before. I'm tempted to add a light, so let's go ahead and do that. We'll put a light on the, come on the chassis and on the tip of the arm. Just little teeny ones for the sake of some sort of decoration. Spotlights are considerably cheaper than point lights. So if you're going to do just decoration lights, generally this is the best way to do it. I think what we'll want to do is just have this illuminate the box. Trying to figure out if I want it attached to a joint or what. I think we'll just have it come straight down like this. And then we will just that. We can increase the intensity, increase the, come on, the 1 pixel that you're allowed to click on, and drag it over here like so. Now the other thing is that we're going to want something on the tip of the arm. Now obviously that is going to have to be on a bone. Come on, duplicate, Jesus. It's going to have to be on the wrist bone. I could put it on the grabber bone, but then it would scale, so I don't want that. And we'll just tip this so that it is pointed out front, like so. We'll give this one a longer range, but make it narrower, like so. And then move it like so. Yeah, that's fine. Go ahead and give it an orange glow, yellow glow. There, that is going to be our arm. Now, how do you set something up for final IK? Well, you add in some final IK and objects. I actually don't remember too much about this, so we're going to go ahead and hit save. And then we're going to go ahead and try and figure out what sort of IK we're looking for. There's some arm IK. There's some limb IK. I have a feeling the limb IK is actually what we want for a robotic arm. No, this is also very bipedal. That's interesting. I'm going to remove that and add in the arm IK, like so. So we're going to need to build a target. I guess we'll go ahead and create just a stand-in 3D object as a target for now. Target. We're not going to want to have that collider though. So this will be our target. Pole target. I don't remember pole targets. Pole position. I don't know what this means. I don't think this was here the last time I used final IK. I don't remember it. Final, that's not how you spell final. Final IK pole target. If assigned, automatically IK pole keeps another axis. The pole axis of the transfer the. Oh, this is the elbow bend direction. Okay. They just changed the name. That's fine. I can work with that. So what's the aim transform? The transform you want to be aimed at the target needs to be a lineal descendant of the bone hierarchy. So we're going to go ahead and make that the grabber. We may change it to the wrist. Yeah, I'm going to have to make it the wrist. And oh, that's not where I want. That's wrong. Wrist. There we go. And then for our pole target, we're going to go ahead and create this. Call this a pole target. And we're going to go and move that to here just to have it be something. We'll drop this in. There we go. Now it gives me an axis and a pole axis. I'll have to fuss with these. This is a little different than I remember, but it's been a while. I've been doing my own IK stuff for so long, you know? Well, the pole weight is currently set to 0, so... So here's our shoulder. Here's our elbow. Shall we see whether or not this works? It does not work. It did something, but that something doesn't look right, does it? So here's what we've got. We've got an elbow sort of thing. Let's move the game over into this corner so you can see. And you can see that what's happening here is there's a red ball floating around. I don't know what that is. I think that's the ship widget. It has nothing to do with the situation. But here's the mechanical arm. And you can see that right now the big problem is we're trying to point at this, and apparently we're trying to point on the wrong axis. So that's obviously not going to work. I don't believe that we have an option to change the local axis that you want to be aimed. So this is the aim axis. Let's try it like that. Is this going to tell me which axis? Yeah, it does. It points. Great. So -1. And our pole axis, which is here. I don't actually know if there is an indicator for that. I don't see an indicator for that. Well, let's try this a little bit better this time, shall we? Okay, so now it is actually being aimed correctly. It's just not moving. Oh, that's because I put on... It's not an arm IK, it's an aim IK. You idiot. Sorry. So I do need this. Okay, so I'm just... Sorry, I'm just an idiot. I was thinking it was an arm IK and it was an aim IK. Boy, I'm just a genius. Bend normal is an odd shape. It's odd. Avatar IK goal. It's not an avatar, so it shouldn't have any of that. Let's go ahead and see what happens. Well, that sticks the arm all the way into our target. And it also seems to be doing some bending. Yeah, see how that gets bent all out of shape? Bend plane normal. Why does it... that's interesting. There used to be something specifically for arms. I've used this before, and it was super easy to set up, but it seems like I have forgotten how to do it. So I don't want to open it in Unity, I just want it to give me the demo. I don't care about how it performs. Documentation. Alright. So there's the aim IK. I don't care about that. Why does it only show me the aim IK? That was weird. So let's just take a look. CCDIK, cyclic coordinate descent, is one of the simpler and most popular kinematic Okay, so maybe CCDIK would be the easiest thing to use. Let's try that. So we're going to go ahead and set the target up as the target. And we're going to want to put in a couple of bones. So shoulder, elbow, and wrist. Only problem is I don't believe this has any of the constraints that we see in other situations. So, damn it, I didn't want to stop it. So right now the problem is that we're not doing very well here. It's supposed to get much closer than that. It's odd that that's considered the closest point, since I can get closer than that manually for sure. Maybe because there's rotation limits and it's just kind of randomly... No, it's the same either way. What I need is specifically an arm IK with a hand element. Should I put in one more? See whether or not the grabber will actually fix it. Oh, that's much better. I'm not sure why it has decided to stop at the lower tip all the time, but to be honest, that's perfectly acceptable. So we'll go ahead and do exactly that thing. I'm trying to get it to release the mouse here. There we are. And then what I'll do is I'll grab this target and move it around. Yep, seems to be... See, it looks like it's stuck. Why isn't that elbow... Oh, it's not willing to bend it. What? That's strange. Why isn't it bending, like, substantially more? After all, it could just bend this way and then bend this one straight up and it'd be very close to hitting. So what is it that's making it do it weird? Why is it not properly pulling here? If I increase the tolerance, nothing happens. Increase and decrease the weight. Oh. Apparently the iterations is actually like an absolute, not a per frame. Interesting. Well, that should be plenty of iterations then. All right. So we'll go ahead and put in that 20 iterations, and we don't need you anymore. But I'm pretty sure that I'm just being stupid here because I know that there is a specific thing that I can use. I just don't happen to remember it. So fabric is an arbitrary one. Full body, biped, limb IK. See, this limb IK is... The limb IK is what I want, but the things that they are saying it has, it does not have. Maybe this is really obsolete. Because the things it's saying it has are things I remember quite clearly. But I didn't see in this particular version. So the other thing that's possible is we could use an interaction system, an interaction object, and an interaction target. But then I would need to create a full FBBIK character, which I don't really want to do. I'm not even sure what that means. Oh, full body IK. Yeah, okay, so that's not what I'm going to do. I have to assign this stuff manually, I suppose. Dopao says you should change the avatar to the hand. Yep, you were right. That's exactly what I should do. I have a feeling that they said that like 10 minutes ago, and I only just noticed. So this target is going to be set to be put at a destination of our choice. So we're going to need to create a new script that can assign that destination, and a kind of script that can call attention to itself as a potential destination. So for that, we're going to want to create some new ship component stuff and some non-ship component stuff. So we're going to call this a harvester arm. We'll open that up. We're going to want to descend from a controllable ship system or a ship system. I'm actually not sure whether I want the controllable system or the default. Let's take a look at what the controllable system is. See, if I do this controllable system, then it can be controlled by another AI component as necessary. Whereas if I don't, then it will be, well, we'll go ahead and just make it a default object for now. We'll try and figure out what the details are later once we've got it implemented, right? So public, what did I call this thing? CDDIK. So is it final IK? So what's the final IK namespace? Right. How can I tell it what to give me here? So if we take a look at the classes, if we go into one of these, can we get... I don't care about this. I just want to know what namespace it's in. Why doesn't anybody tell you the namespace that they're using? It's ridiculous. Is it... No, that is a Twitter. That's not going to be much help. Is it root IK? Root motion. There it is. Of course, root motion. That's exactly what you'd think of as your default, right? Makes perfect sense. All right, so then we can do public cdd ik. No? Okay. So it's not called cddik, apparently, because it's not in here. Cyclic coordinate descent, maybe? IK solver CCD, is that what it's called? Jesus. Keep the names in the inspector the same as the names in the code. All right, so there we go. And that's going to be something that we're going to want to have assigned, and then we can move the target around. Actually, we don't even need this assigned, do we? Not necessarily. Let's go ahead and continue on without it for a moment. We'll come back to it when we need it. Because what we really need to do is search for nearby grabbable objects. So public float attention range equals 10. And then what we're going to want to do is have another class, which we'll call harvestable object. And we're going to put that in the same namespace, even though it doesn't really make a whole lot of sense because it's not a part of a ship, but it's an integral part of the ship setup at the very least, you know. It doesn't make sense without a ship. Well, maybe we'll change where it is later. But either way, the harvestable object is just going to keep a list of all harvestable objects that are active in scene. So public list harvestable object. And by that I mean public static list harvestable object active equals new. And in awake, we're going to want to add ourselves. And in on destroy, we're going to want to remove ourselves. Boom. We'll figure out exactly what that's going to be later on in terms of additional functionality. But what we're going to do here is we're going to continually monitor for harvestable objects that are within our harvester arm's reach. For each harvestable object, in harvestable object dot active, float range equals ho.transform.position minus transform.position. If range is less than attention range, we'll just go ahead and attract to the first one. I guess we'll break rather than... focus. And we'll do void focus harvestable object Harvey. And then what we'll want to do is move the target to the harvestable object. So we're going to need to keep track of that with a public transform target. So down here we'll say target dot position equals Harvey dot transform dot position. Like so, right? Any bugs? Yeah, I got some bugs. Boom. Still any bugs? Yeah, I got some bugs. Oh, that's the reason I had a close paren. I was halfway through writing it. There we are. Boom. All right, so what we're going to do is we're going to put a harvester arm here on this object. Oh, that's not a harvester arm. There we are. And obviously the target's going to be the target. We'll go ahead and make this target nice and small, because it's only for indication purposes at the moment. You know, a range of 10 seems kind of small. We'll give it a bigger range. And then what we'll do is we will go over here to this thing here, and we will give this a harvestable object indicator. It's actually not, that's not what we want to have the indicator be. Let's put it on the CPU for now. Boom. So with that in mind, we're going to need to attach this mechanical arm to the ship so that we can actually use it. We're going to need to do a lot of stuff with this mechanical arm in the long run, but for now we're just going to dump it in here as an uninitialized ship part. It doesn't have colliders or anything. It's just going to randomly attach to the ship, and that's all. So there we go. Now when we hit play, our game is going to open up in the wrong tab because I moved it. I'm going to move it into the correct tab so we can see it. All right. So we've got that arm on our head, as you can see. And what we'd like to do is get close enough to this object to have it try and attach to it. Ooh. Oh. Wow. Okay, so the range is not as long as it first appears. So the core problem that we've got right now is obviously this box is much, much, much too big, which I knew. I just didn't bother to fix it. It's also kind of pointed the wrong way. There are a lot of things that we can do in terms of limiting the harvestable objects to only being harvestable from certain directions. We'll deal with all that stuff later. Yeah, like that. Perfect. However, notice that the target remains floating off in space even when the object is no longer in position. So what we're going to want to do is have that target save its position. So protected vector3 local target position default. And then here in start, we're going to go ahead and say local target position default equals target.local position. And then down here, we are in fact going to return. And then down here, if we get here, there's nothing in range, and we can set our target. So if target.local position does not equal local target position default, then target.local position does equal that. And that should give us a nice snap, which is fine. Now, I'm writing this all in mind with switching this out for my own code later on. There's nothing in this that is final IK dependent, because all I'm doing is moving a transform, and that is something that is, pretty acceptable in general, as long as there is a transform that is the target. So that makes this quite a bit easier than if I need to switch away later. This will do a much better job than if I was writing something deeply integrated. Boop. Of course, now the problem is that we want to actually fetch the harvester arms harvested, the harvest. So we're going to want a public enum harvest arm state. We're going to want waiting, harvesting, carrying, and deploying, and dropping. So public harvest arm state equals harvest arm state equals waiting. And then what we're going to want to do is have a situation where we have a couple of specific things in mind. So trying to think of something here, because is it snapping? I think it might be snapping. I really don't want it to snap, so I might have to have it set the animation weight so that it doesn't snap. See how it snaps? I can't have it snap. Snapping's no good. I could also just move the target rather than snap the target, which would make more sense, wouldn't it? Void move target vector3 target destination. And we will go ahead and say target.position equals, and then we're going to want to bool local equals false. So if local, so we'll go vector3 d equals target.position. No, vector3 d, just d. Vector3 pause. There we are. If local, then pause equals target.local position, else pause equals target.position. And then what we're going to want to do is move that. So move towards pause and then the target, which is going to be a target destination. And then the max distance, which is going to be time.delta time times arm speed, tracking speed. And obviously, we're going to want public float tracking speed. I'll go ahead and make it 5. And then what we're going to want to do is this same thing, but backwards. So then down here, when we do this, what we'll do is we will go ahead and move towards it instead. Move target, local target position, default true. And down here, we're going to go ahead and do move target. Harvey.transform.position. Boom. And that should take care of the snapping. And once the snapping is taken care of, I'm able to retract the arm and put the stuff in a destination as required. Boom, 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 boom. Snack. Perfect. So what we're going to need now is a destination inside of the mechanical arm for dropping things in the box. So that's just going to be in here. There we go. Box target. Yep. Cargo target. And we'll go ahead and have that be something that we set. And that will never move. It's just there so that when we are retracting the arm to deploy, to deposit something, we will be able to do exactly that. So we're also going to want to have protected transform. I guess it's not a transform. Protected harvestable object, cargo, gripped. There we go. So what we're going to want to do here is have the move target return a value. So if pause minus target destination dot magnitude is less than 1, return true. And that will allow us to, I guess we don't even have to do just return that, yeah. That will allow us to quickly determine whether or not we're in range. So down here, when we're focusing on it, we can say if move target, then we'll want to attach Harvey. Void attach harvestable object Harvey. And when we do that, we're going to say harvey.transform.parent equals, we're going to need to have a grip here. Dot set parent grip. And then we're going to want to set our state to retracting. Like so. And we're going to want to go ahead, before I forget, we'll put this grabber in its position here. Apparently I have barf in here somewhere. God damn it. Why is that illegal? What? What am I not seeing? What's going on here? Why is this? I don't see this problem. Oh, it was just a big fuck you. Well, thanks, and fuck you too. Alright, so now that we've got the grabber set up, what we can do is set the grip and then set it to harvesting. And what we're going to want to do is here an update. We're going to send out to various other functions, depending on what the state is. Void fetch, or void, what did I call it? Wait. And we'll drop this in there. And so here we're going to have a switch state. Case waiting, break. Case carrying. So if we are carrying, what we're going to want to do is move the target towards our cargo. So if we move the target towards our cargo, then we're going to want to... Why is it inserting random crap here? Did I type that and just not see it because I haven't had enough sleep, i.e. any sleep? Maybe. So if we get close enough to the cargo target to try and drop something, then we're going to go ahead and just delete the... oh, not delete, disable the thing we're carrying, but we have to set it first, and I forgot to do that. So gripped equals Harvey. So here we're going to go ahead and say if not gripped, debug.log error trying to carry nothing, and state equals waiting, and break. Otherwise, if we've moved close enough, then gripped.transform.setParent, and then we will set it to the cargo target, and then we will say gripped.gameObject.setActive false, and then we'll say state equals harvestarmState.waiting. Now we could go and make this more complicated with an actual dropping animation, but I think we can wait on that. See, the harvesting and the dropping are both things we're skipping right now. Let's just go ahead and delete them. We'll bring them back later if we need them. So, in theory, that will actually go out and fetch stuff. Break. Now let's see whether or not this actually retrieves the chip. It should. Boop. Pop. Perfect. Got the chip. However, it looks like it's not dropping the chip. I think that it can't get close enough to the internal object. You can see how it's kind of stuck. If we take a look at the grabber, it's still got the CPU attached, although it's disabled. Oh, I know what the problem is. The problem is that we set active to false, but it's still in the list of things that can be harvested. So it didn't get removed here. So void on disable. There we are. Now it should properly fetch it and then retract it, and should work. Although I'm a little bit confused. Well, it doesn't matter. We'll see shortly whether it works or not. Boop. Merp. Soup. Perfect. All right, so the next step is to make all of those objects fetchable. So all of these need to be harvestable. We'll go ahead and harvestable object all of them. And now what we should get when we get close is that the arm should go and collect all 4 targets. As expected, it went and fetched all the targets. That little floating thing that that you might have noticed is the target object itself, which we haven't turned invisible yet. There we go. So let's go ahead and turn it invisible, since there's no reason to have it be visible. It doesn't need to actually be active. Also, I think that this is a little small in the end. It's just a little too small to clearly see that there is stuff there. So we're going to go ahead and make it grow a little bit bigger and try one more time. JojoJet came by. Hello, JojoJet. Been a while, I think. Unless you've been quietly watching before. We're working on the second part of the gameplay here. The first part is scanning stuff, and the second part is retrieving stuff. Meep, zoop, zoop. Oh, I went too far. Grab it. Gonna need to do a little bit of work on this, I think. Perfect. It's not as pretty as I'd like, but I have a couple other options. One is that I could retract the target to the default position. And then retract it into the basin, because that way it would avoid the situation where it clips through stuff. Another thing is, I think this mechanical arm is a little small. Let's go ahead and make it a little bigger and give it a 30-meter range here. And we'll give it a tracking speed of 8. Now with that in mind, we're going to have an additional state for our harvester arm, which is going to be weighting, carrying, and dropping. Yeah, that's fine. So right now, if it goes into carrying, it does this, but this is actually dropping. With carrying, we have a slightly different situation. Instead of target position for the cargo target, we're going to go ahead and deploy it back towards the default. Here it is. If that, then we'll want to change the state to dropping and break. That way we will get like a retract and then a drop, which is much, much better in terms of not clipping through crap. We also might go for some vector constraints on which direction the arm is allowed to try and reach, because right now it'll happily reach straight through the hull, which is kind of stupid, but whatever, right? I'm moving the default target to be a little bit further up. You can see how the default target ends up being this sort of kinked approach, which is kind of interesting. It's not really what I want, but it should work. We'll go ahead and deal with it later. JojoJet says, "Are you still working on the Galactic Line?" So it's kind of so it's an interesting situation because the Galactic Line is very big, and the biggest problem with it is that I now need to do roughly 800 hours worth of character art, and I don't even have the skills to do that right now. So what I'm doing is I'm working on a game that has some of the same fundamentals, and will be able to use most of the same assets, with the idea being I'll be able to get this out in a reasonable amount of time and then build on it. Perfect. I still forgot to install a GIF capture. I'm supposed to have a GIF capture on this, but I forgot. If I put this same exact spot, will it properly stay still? Yeah, it's actually going to stay pretty still. So we're going to go ahead and try this so that we don't have a weird kink to Kimbo default. Yeah, it's not obeying any sort of joint constraints at all. It's like, whatever. Um, I think that there are probably ways to give it joint constraints. Final AK is a pretty nice product. But I don't happen to know it off the top of my head. I can use rotation limits. I'm not actually sure what that'll do. Let's give it a shot and see what happens. Of course, the fact that we can pass through it is obviously a dumb feature that won't exist for long. I couldn't actually tell whether that was any better because I was busy passing straight through it like an idiot. I need to improve our deceleration, I think. The piloting in general needs to be cleaned up a little bit more before I feel comfortable with it. I don't know. I think that did feel a little bit better. This is definitely a Giphy situation, though. It's something where it would be a lot nicer if I could just install a GIF capture rather than sharing screenshots, because obviously this is not very screenshotty. Let's see. I know that there is some GIF capture stuff. Unity GIF capture. I know there is some open source stuff too. Drop the recorder into your folder. Okay, I can do this. So I'm going to have to do this after. It's going to require me to actually move files around and shit. I don't feel like doing that on camera. All right, so that's the wrong browser. That's the right browser. So I think that you're actually giving me a screen to GIF thing, and I don't need that. I wanted a Unity specific one so that it would just be the gameplay. And there are lots. I just don't have one installed right now. But thanks for the advice. I'm sure that's a good general purpose one. Still, what I'm gonna do is install that off camera. I'm not going to make you folks watch me try and install a GIF system. But I will try to take a screenshot or two. It's off center. Let's go ahead and make it so that it centers them when it grabs them. I was thinking about whether it would be more or less confusing if it tried to center them. And I guess it's more confusing. So, Harvey.localPosition.transform.localPosition equals identity. Oops, wrong button. Wow, that didn't work out at all. I'm not very good at this today. And it's really because, well, it's the same thing that space engineers ran into. For a long time, space engineers would decelerate you at 10 times the force that your engines could actually accelerate. They turned that feature off because it didn't make any sense. But it does mean that all of the ships don't feel quite as snappy anymore, and I'm definitely having that problem here. All right, let's go ahead and paste in some screenshots. So, making my salvage arm. Made my salvage arm because I'm done. I'm going to be quitting fairly soon here, so if you guys have any questions, this would be a good time to ask them. I seem to be getting these done in about an hour and a half these days. I actually slate them for more than that. I slate them for 2 hours, and then it ends up not taking quite that long. Ah, there it is, the game. Can't really see it from the game perspective, though. Oh no, I went too far. Oh, grabbed it just barely. All right. So now I have tweeted. Dropout says I should move approximating on some sort of curve. Yeah, right now Final IK is just, I'm just using the defaults here. What I really should do is use my own solver. I have several of my own solver. I just didn't feel like programming them again, and I thought that Final IK had some pretty nice stuff with this. They changed it, and I can't find the stuff that I was used to. The LimIK is supposed to have all of the features I need, but it doesn't. The actual thing I looked up on how to make this work uses the old things that I'm used to, but this doesn't have them, so I'm not sure what's going on. It's clear that Final IK changed how things work, and now I'm not sure how to give things an elbow. So we're going to go ahead and let that be. I'll definitely be replacing it with my own script in due time anyway, because I'll eventually have to start giving out the code. But for now, we'll go ahead and leave it as is. It works well enough. It feels well enough. So it's fine. Boop. 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 So really what we'd do is we would have this attached to an object. It wouldn't just be floating in space, so it'd be like something like here. Oh, darn it. There. And it should probably have a light on it so that we can see it. So we'll go ahead and add in a light. No, not a directional light. That's much too much light. We could add in a point light. That would be realistic, but a spotlight is so much cheaper. And we'll go ahead and make this an orange light as well. It's a little too bright. It's a little better. We'll just move this. Oh, come on. There, like that. And hopefully that should work. Hit play. And let's go ahead and take a look at how this feels to drive by, because the point is that this is all about piloting in a way where you're rewarded for doing close drive-bys. Neat. Zoop. 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 And away we go. Normally they wouldn't be all 4 things in there, but that's fine. I think that felt pretty decent. I think that we are definitely on the right track. Oh man, this feels so good when you start to understand how that glowing lines, how those glowing lines actually work. It feels like you can just do anything because you understand exactly where you're going. And even then, when I had that giant thing in my way, I thought, I'm not going to hit that. Even though it was directly in front of me, I knew I wasn't going to hit it because there were no lines on it. It actually feels really nice. I think this might have some fun legs to it once I get it running a little bit better. The big thing I need to fix for the piloting, the 2 big things I need to fix. One is vertical movement, because I've got a couple of asymptote problems. And the other is that I've got to make it stop a little bit faster. Whoa. I got confused because I had something big and dark in my way and I couldn't see what was going on. All right, well, thank you very much for joining me. I'll be back on Wednesday and next Sunday. We're making steady progress on this little hobby of mine. Hopefully, it'll be playable in some form relatively soon, and you can have fun piloting it around and playing with it. I still have to decide on random debris generation and whether to do that or whether to just create arbitrary levels that load in. Not really sure. The arbitrary debris sure would be nice, but it's not that much of a challenge to create my own levels, and it would be kind of fun. So maybe I'll create my own levels first, and then, I don't know, fill in with arbitrary debris. Either way, we ended up getting some stuff done, and I'm happy with the result. So I will see you folks later. Where's the stop button?